Review for test 5.2, exponential functions. Problem number 1 says the table below shows the population P of mice in a field at the end of M months. Based on the data in the table, what will be the population of mice in the field at the end of 8 months? So here I see that my table only goes up to 4 months. So what we have to do is write an exponential regression from this data. And then we're going to replace x with 8. Or m. Here we have m. So let's go ahead and change those to x and y. So what I'm going to do is in my calculator, I'm going to add a list in spreadsheets. And I'm going to title each column x and y. And then I'm going to enter the data that I have. So the first set of data I have is 0, 1, 2, 3, and 4, talking about the number of months that have passed. And y values are going to be my population of mice in a field. So I have 6, 12, 24, 48, and 96. So then I'm going to add a data and stats page. So control doc, add data and stats. And I can change my axes. So the bottom, the horizontal axis is x. The vertical axis is y. And I see that I have a nice exponential trend here. So then I'm going to go to Menu, Analyze, Regression, and we want to show exponential because we saw that that was an exponential trend. So my equation is going to be y equals 6 times 2 to the x power. So I'm going to write that down. So we've got y equals 6 times 2 to the x power. The question was, how many mice are there at the end of 8 months? So I'm going to replace x with 8. Here, that's going to be 6 times 2 to the 8th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, or control doc, I'm going to add a calculator page. So I have 2 to the 8th power is 256, and then 6 times 256 times 256 is 1,536 mice. So I wrote that down on my paper, 1,536. Problem number 2. Number 2 says the number of stores opened by a coffee company can be modeled by the exponential function graphed on the grid, where x is the number of years since 1992. Notice this is like yesterday's problem with the coffee shops. So 0 is our starting year. So 1 year, that's 1 year since 1992, so that's 1993. 2 years would be 1994, and so on and so on and so on. So let's see, based on the graph, which statement does not appear to be true? Not. That's a very, very, very important word. Not true. So let's take a look at answer choice A. It says the coffee company has opened 400 stores by the end of 1992. So the end of 1992, that's going to be right there, because that's the beginning of 1993. So 400 stores, they've opened 400 more stores. That would mean that we went from 400 to 800. So that one, not true, because that looks more like 500. Okay. B, the coffee company opened 100 stores in 1 year. So the first year it looks like they opened 100 stores, but from the first to the second year, it looks like they opened a few more than that, and then a few more. So let's come back to B. B is a possibility. C, every year the number of stores in the coffee company open increased by 25%. That's a possibility. D, since 1992, the coffee company has opened 250 stores each year. Well, this Here, each year implies that this would be linear, and this is obviously not linear, so I'm going to eliminate D. So, let's test this 25%. Here at 4 years, that's 1,000. 5 years, it's about 1,200. So is that about 25%? So 1,000 divided by 1,200. It's about 83% growth. I don't know. Let's see what else we can do. So to test this 25% theory, what I'm going to do, no, don't save, is I'm going to create a list in spreadsheets for the data that's given. So we have our X values, the number of years since 1992, Y values, the number of stores. So here, 0 years, we have 400 stores. 1 year, it looks like we have 500 stores. 2 years, looks like we have 600 stores. So far that looks like growth of 100 stores in each year. 3 years, it's almost 800 it looks like. I'm going to go ahead and say 800. 4 years, we have 1,000. 5 years, we have 1,200. 6 years, it looks like we've got 1,500. 7 years, 1,900. 8 years, 2,400. Data and stats. Change this to Y. Change this to X. So this looks a lot like that graph that we have there on the review. Menu, analyze, regression, show exponential. So here, that 1.25, that's 25% growth. So I would say the best answer would be C. Because the coffee company opened 100 stores in 1 year, but it doesn't say which year. Three, identify the following key attributes about the graph. Our initial amount, remember that's the y-intercept, is 1. The base, that's our growth. So here we have 0, 1, 1, 2, 2, 4, 3, 8. So let's go ahead and find that base. So from 1 to 2, that's an increase of twice as much. 2 to 4, that's an increase of twice as much. 4 to 8, that's an increase of twice as much. So I would say our base is 2, because it's doubling. Those y values are doubling every time the x values increase by 1. The asymptote is y equals 0. So the equation for this exponential function here is going to be y equals 1 times 2 to the x. Our domain, all of the x values for this problem. So we don't have a smallest x value because we have that arrow pointing to the left. It's going up and to the right, so my domain is going to be all real numbers. And our range, again, the function is increasing. It's growth, so it's pointing up, so it's going to go up forever. So it's all of the y values bigger than, but not including 0, because it gets closer and closer and closer to that y value at 0. So it's y is greater than 0. Number 4. Number 4 says a table of values for the exponential function f is shown below. Which situation could describe this function? I see a lot of similarities in these answer choices. So first I see, well, A and B both have the words increases. C and D both have the words decreases. And we have 2 3/4% per year. And then by $3,850 per year. And then we have again the 2 3/4% and again the $3,850 per year. So let's look at this table here. First, let's decide, is this increasing or decreasing? So here we've got 140,000, 143,850, 147,806. So these are increasing. So I'm going to go and eliminate the two answer choices that say decreasing. Next, we have to decide, is it increasing by $3,850 per year or 2 3/4%? So the first year increases by $3,850, but from the second to third year, it does not. So if I have 147,806 minus 143,850, 6, 5, 9, 3, 3,956. So that's an increase. Also, if we're increasing by a set amount every year, that implies that that's a linear function. And it clearly says here for exponential functions. So the answer has to be A. Number 5. A toy is made up of cylindrical rings stacked on a base as shown in the diagram. The diameter of ring 1 is 87% of the diameter of the base. For ring 2 through ring 7, the diameter of each ring is 87% of the diameter of the ring directly below it. The diameter of the base is 5 inches. Which function can be used to find the diameter in inches of ring R, where 1 is less than or equal to R is less than or equal to 7? So all that means is, which equation would help me find the diameter for any of these rings? And it says 1 is less than R, is less than or equal to R is less than or equal to 7, because here's your base. So this is ring 1, that's R, 2, R, 3, R. So they're naming these all R. That's all they're doing. So here, since the diameter of the base is 5 inches. So the first thing I'm going to do, I'm going to look at all the similarities like we did in the previous problem. So we know that the equation y equals a times b to the x, a is the initial amount. So I can eliminate B and C because their initial amounts is 0.87. Now look at A and D. A says times 0.87 to the R power. D says times R minus 0.87. So D is a linear function. Here I see that each diameter is 87% of the previous ring. Here this says 87% of the previous ring. So the correct answer would be A. Number 6. Number 6 says Betty currently has $200 in her savings account. If the account earns 1.5% interest each year, write an equation that could be used to determine the total number of money Y she will have after X. And I changed this to years. Okay, so our initial amount, A, is $200. And the account earns 1.5% interest. So what we're going to do, if it earns, that's an increase, we're going to say 1 plus 1.5% interest, that's 0.015. So my B value is 1.015. So to write the equation here, I'm going to say Y equals 200 times 1.015 to the X power. Number 7. A particular bacteria population on an athlete's foot doubles every day. If there are initially 50 bacteria, how many bacteria Y will there be after X days? So first we have to write an equation. So doubles every day and initially 50 bacteria. So my A value is 50 because we start with 50 bacteria, and my B value, it's doubling every day, so we're going to multiply by 2. So my equation is going to be Y equals 50 times 2 to the X power. So to solve this problem, I'm going to replace, oh, that is the problem solved. It doesn't ask us an X number of days. We just want to know generally how many days. So my answer is Y equals 50 times 2 to the X. Number 8. Identify the initial amount A and the rate of decay R as a percent of the exponential function. Evaluate the function when t equals 3. Round your answer to the nearest tenth. So A, we have g of t equals 240 times 0.75 to the t power. So in this first problem, my initial amount A is 240. My growth rate, or decay rate in this case, B, is 75%. I'm going to move that decimal over twice, so I have 75%. And to find g of 3, I'm going to replace t with 3. So that's 240 times 0.75 to the third power. So here I'm going to use a calculator. New document. No. Add a calculator. And we're going to multiply 240 times 0.75 to the third power. And we get 101.25. Same question, different function. Here I have f of t is equal to 475 times 0.5 to the t power. So my initial amount is A, 475. B, my rate of decay is 0.5. So to make that a percent, I'm going to move my decimal over twice. So that makes that 50% because we have to fill in that blank spot with a 0. And finally, f of 3. So f of 3 equals 475 times 0.5 to the third power. So again, I'm going to use a calculator to evaluate. 475 times 0.5 to the third power gives me 59.375. 59.375.